Hello everyone, I'm Safide Jalilpour and this is my second episode with you. Last time we talked about the relation between painting and literature, so if you haven't listened to that episode, go ahead. Today we're going to talk about music and language. Keep in mind that this episode is going to be presented in two parts. In this part, we'll talk about music and neuroscience. Are you ready? Let's start. Can music shape the way we think and use language? It's a fascinating question, and one that psychology and neuroscience have only recently started to explore. Studies show that music doesn't just make us feel good, it actually boosts performance in different areas of life. It even changes the brain itself, its structure, and the way it functions. These changes seem to be especially powerful when it comes to language. In this episode, we'll first look at what brain imaging research tells us about musical training, and then we'll explore how music affects language processing. And finally, we'll talk about where this research might be heading in the future. Thanks to modern brain imaging techniques, neuroscience can now ask a big question. Does intensive musical training actually reshape the brain? And if it does, how might that affect our thinking and other abilities? Researchers usually rely on two main approaches. The first is direct techniques, like ERP, which track the brain's electrical activity, and MEG, which measures its magnetic activity while we are engaged in mental tasks. The second approach is indirect. For example, fMRI doesn't measure electrical signals. It looks at blood flow in the brain to see which areas are more active. Brain scans tell us something fascinating. The brains of musicians look different from those of non musicians. For example, one well known study by Shalog and colleagues in 1995 showed that musicians have a larger anterior corpus callosum. That's the part of the brain that helps the two hemispheres communicate, especially important for complex movements. Other studies have pointed to differences in several key areas. These include regions linked to memory and pitch, motor skills, hearing, attention, language, and even coordination. In short, music seems to leave its fingerprints all over the brain. But this raises an important question. Are these differences mainly the result of early intensive training, or do some people simply have natural brain traits that gives them an advantage? The evidence suggests that nurture, the training itself, plays a major role. Let me explain. In 2002, Schneider and his team found clear evidence that experience can actually reshape the brain. They compared three groups: people with no musical background, amateur musicians, and professionals. Each group listened to tones while watching a silent movie, and their task was to pick out unusual sounds while their brain activity was recorded. The results were striking. Professional musicians showed much stronger brain responses than non musicians, and they also had more gray matter in certain areas of the brain. Even more interesting, the changes in brain structure were closely linked to the changes in brain activity. In other words, musical training doesn't just affect how the brain works, it can also change how the brain is built. Another way scientists study the brain is by looking directly at its activity. They use methods like ERP, which track electrical signals, and MEG, which measures magnetic fields in the brain. In these experiments, musicians and non musicians are often asked to do different tasks, like typing with their fingers, listening to melodies, or trying to remember musical patterns. The idea is to see how well they can tell sounds apart, or how they process changes in harmony, melody, and rhythm. Now, the research here is massive, but let's focus on what matters most. Studies show that musical expertise really does shape the way we process sound. Brain scans reveal that these changes take place in specific areas of auditory cortex and the superior temporal gyrus, regions deeply involved in hearing and sound interpretation. And it doesn't stop there. Other studies found that music training can even affect how we combine information from different senses. For example, a study by Laff and colleagues in 2008 showed that musical training doesn't just tune the ear, it also links together hearing, vision, touch, and movement. This kind of sensory motor auditory training points to one big idea: music has the power to rewire the brain. One elegant study by Schultz and colleagues in 2003 explored how flexible or plastic the auditory cortex really is. They created a special melody made of complex sounds. Interestingly, its main frequency was missing, so the melody could only be recognized if listeners perceived the virtual pitch of those absent tones. At first, participants couldn't hear the melody at all, but after training, they were suddenly able to perceive it. Brain recordings showed something remarkable: a boost in gamma activity, which reflects the brain's ability to integrate or bind together information at a higher cognitive level. Even the exact brain areas responsible for these effects shifted slightly after training. The big takeaway: musical expertise doesn't just sharpen hearing, it reshapes the brain's network. The stronger the expertise, the stronger the brain's electromagnetic responses in the auditory cortex. In short, learning music doesn't just teach us to play an instrument, it actually changes the brain. Music training affects behavior, reshapes the auditory cortex, and improves the way we process sound. These changes happen both in the structure and function of the brain, and they are closely linked to the real improvements in cognitive and auditory skills. So, this is the end of part 1 of this episode. Stay tuned for part 2. We will talk about music and language. Till the next time, bye!